Good morning, everyone. Am I audible? Am I audible, students? Clearly, please write in the chat box whether I am audible or not. Good morning. I am audible, right? What happened? You are not there, what students? Please write in the chat box whether I am audible or not. Can you hear me? Okay, finally, Wilson has replied. Okay, thank you, Wilson. I thought nobody is hearing me. Okay. My voice is low. Is it? How come? Just wait. Let me check. Is it okay now? Is it okay now? Is it okay? Background noise, there is no background noise. It's fine from my side, okay? Everything is fine from my side. So shall I start? Okay. So last class we have done about your the systems of sewerage, right? So today I hope everybody has written in your copy. If not, then you write down in your copy, okay, the last class notes. Okay, so for today under your system of sewerage, we shall discuss about the. Okay, today please be ready with your copy also, copy and a pen. We are going to do one numerical today. Okay, so if you are not ready with your pen and copy, you just go and bring your pen and copy. I'm giving you 1 minute. You go and bring. Everyone, be ready with your pen and copy. Okay, those who are joining now, we shall do one numerical today. So you bring your pen and copy along with you. Okay. So should start. So today, first we will discuss about the factors that affects the quantity of sewage. Okay, or you can say dry weather flow. So dry weather flow, in short, you can write as D.W.F. So what is dry weather flow? Actually, from the name itself, you can make it an idea that dry. It is the you can say it is the average daily flow to wastewater treatment work. Okay, or it is the average daily flow to a treatment work and during a period of no rain, okay, or during where when the the season is dry, when there is no rain. So the average daily amount of water that flows through the treatment plant is known as your dry weather flow. Okay, so let us see what are the factors that affects the dry weather flow. So number one is your population. Obviously, the quantity of sewage, it will depend upon the population of a particular town or city. Okay. So what will happen if the population increases? So the quantity of water, it also increases along with the population. So what we need to do is that we need to do a forecasting method so that we can be ascertain about the population of the next 2 or 3 years, and accordingly we can design the water requirement of that particular town or city. Okay, so number two is your nature of area, like it also the quantity of sewage that is produced in a particular area. It also depends the quantity of sewage, it also depends upon the area, whether the area is a residential area, or whether the sewage it is being produced from a commercial area, or whether it is being produced from an industrial area. Okay, so in a residential area, so what it is taken, the quantity of sewage that is being produced, it is equal to the quantity of water, okay, that is supplied to the consumers. Okay, and in industrial area, the quantity of the sewage, it generally depends upon the types of industries. Okay, so the quantity of sewage, you can say that it varies with the type of industries. Okay, so and then next is your then infiltration. So what is infiltration? The water, okay, the rainwater, you can say when there is a rain, so the water, it seeps through the ground. Okay, it seeps through the ground, and that is known as your infiltration. Okay, the soil pores which absorbs the your water when there is a rain, so that is known as your infiltration. So here what happens, some quantity of groundwater, or you can also say as a subsoil. So what happens, due to some leakage in the pipes or sewers, so what happens, some quantity of groundwater, it may infiltrate into the sewers. Okay, and this happens only when the head of the groundwater or subsoil, okay, so it is surrounding the sewers, okay, it is surrounding the sewers, and it is more than the head of the sewage or wastewater flowing through the sewers. Okay, so next is your rate of water supply. So rate of water supply is what? You see the quantity, it's written here, the quantity of sewage varies with the rate of water supply. Okay, so the water supply, it is not constant throughout the day. So it varies with the hours of the day. Then again, it varies from day to day, or even it is varying from season to season. Obviously, everyone knows this. Yes. So it is it is required to estimate. So to estimate the quantity of sewage, the rate of water supply, it should be taken into your account. Okay. So. Uh, this 4 points is all about your factors affecting the quantity of sewage or your dry weather flow. Okay. So next is your determination of rainfall intensity. So, to determine the intensity of rainfall, there are certain formulas. Okay, certain empirical formulas are there. So here, nothing to explain. Okay, so you should see here. You need to remember the formulas. Obviously, you need to remember the formulas. So, number one is your general formula is there. Okay, that is your I is equal to A by T plus B. Okay, so what is A? A and B are your constants. Okay, and I is the intensity of rainfall in millimeter per hour, and T is the duration of storm in minutes. Okay, so like this, your different formulas are given. Okay, number two is what? For localities where rainfall is frequent. Okay, then number C is what? For storms occurring once in a year. That is, you can say in a dry place. Okay, so for that places, your this formula is to be used. Okay, and then what is number four? For storms occurring once in 10 years. So that is a very place where it is very rare, where there is no rain. Okay, it is occurring once in 10 years. Okay, so these are all very rare. So this formula is used in that kind of cases. And number five is your Quichling's formula. So Quichlin, he gave two formulas. Okay, so one is your for storms occurring once in 10 years, and the other one is for storms occurring in once in 15 years. So two different types of formulas he have provided, Kuchling has provided. Okay, so these are the formulas. Okay, so now again, uh, that is all about your intensity, to find the intensity of rainfall. Okay, so now the next formula is your estimation of stormwater flow. Okay, estimation of stormwater flow. So here you see what is written here. When rainfall takes place, a part of it infiltrates into the ground surface, and the remaining part flows over the ground surface. So just now, as I told, so when rainfall is happening, so what happens to the water that is falling to the ground? A part of it, maximum part of it, it infiltrates into the ground. Okay, it infiltrates into the ground, but when the capacity of the soil pores now it is filled up, it cannot accept more of the water. Okay, so when it is unable to accept more of the water, so what will happen? The rest of the water, it flows your over the ground surface. Okay, so that is known as your runoff. Okay, so these parts, these things, everything you will be learning in hydrology also. So the remaining part, it flows over the ground, and that is known as your runoff. So now the part of the rainwater, that is flowing over the ground surface, it is commonly known as a stormwater or runoff. It is written here, just now I explained. So which needs to be drained through the sewers. Okay, so this runoff, it needs to be drained through the sewers. Okay, that is pipes. So otherwise the entire area will be flooded. Obviously, if runoff is happening and that water it is not being drained out, so what will happen, that entire area it will get flooded easily. Okay. So for the design of sewers, it is necessary to estimate the quantity of stormwater. So for if someone gives you to design a sewer, so obviously first you should know that how much quantity of stormwater is happening in that area. Okay. So first of all, you need to estimate the quantity of storm water that will reach the sewers. Okay. Then the quantity of storm water that will reach the sewers, it will again depends upon what? It will depend upon intensity and duration of rainfall. Okay. It will again depend upon the intensity and duration of rainfall. Then again it will depend upon the characteristics of the catchment area. So what is a catchment area? Where the area where the rainfall is happening, the particular area, or you can also say that it is a drainage area. Okay. So it depends upon all those things. Also it depends upon its drainage area or catchment areas, shape, then topography. Okay, whether there are depressions or water pockets, so all those things it will depend. Okay. So for estimating the storm water or the rainwater, or you can say in other words the runoff. Okay. For designing the sewers, there are two methods that are being adopted. Okay. Number one is your rational method, and number two is your empirical formula. Okay. So number one is a rational method. So this one is the formula KIA divided by 360. Okay. So what is K? K is your runoff coefficient or impermeability factor. Okay. Then your I is your the same thing, intensity of rainfall in millimeter per hour. Okay. Then A is your catchment area. Okay, that is in hectares. Clear? And what is Q? Q is your storm water in cubic or meter cube per second. So also the Q you can write as a Q. It has one formula, that is your 2.8 KIA. Okay. So if you write 2.8 KIA, so that unit it will be changed to liter per second. Okay. So it will be changed to liter per second. Otherwise your Q, it is the unit of Q, it is in meter cube per second. Okay. So it is a discharge, you can say. Okay. So next is your empirical formula. So empirical formula, there are different types of empirical formulas given here. You need to memorize these formulas. Okay. So number one is your English formula. This is given, this English formula. Then your Fanning's formula. I will zoom it. This is Fanning's formula, then Talbot's formula, then Reeves' formula, and your Dickens formula. Okay, so these five are the formulas. You have to remember it by anyhow, because you need to do the numericals. So generally, in our classwork, we won't be dealing with these formulas. Okay, so basically, we will be dealing with your empirical formula and all this rational formula. We will be dealing with today. Okay, so now we have the numerical as you see here. You write down the question first. Okay, you write down the question. So if you do it in your copy, then it will be more clear to you. Okay, so you first you write down the question. It's a short numerical. It will be completed in 5 minutes. You can complete it. So first you write down the uh, your question. Okay, I hope everyone is listening to me. Okay, so you write down the question. Okay. So I hope you have written the question. Okay. So first, in this question, let me read it out. It's written that a catchment area of 20 square kilometer, it consists of two-third rural and one-third urban area. Okay. So the rainfall in the area, it is recorded as 25 millimeter per hour. So the question is, find the quantity of storm water in the area. So we have the formula. Just now we got the rational formula. Okay, this one, KIA divided by 360. Okay, so area, it is given. Okay, then intensity of rainfall. What it is given here in the question. Let me see. Okay, so intensity of rainfall, it is given as your 25 mm per hour. Okay, so now the question is here, basically the area, it is, one is your rural area, that is your two-third, and one-third is your urban area. So now, yeah, the total area is given. Okay, it's 20 square kilometer. Just wait. Okay. So the total area, it is, you write down. Okay. You write down accordingly while I am explaining in your copy. Okay. Then it will be finished. The so total area, it is given as your 20 kilometers. So we are converting it to your square meter or meter square. Okay. Kilometer to meter square. So it is your 1000 multiplied by 1000 square meter. Okay, so now we need to convert it to hectares, because in the formula, q is equal to KIA, there your area is in hectares. Okay, so we need to convert the area to hectares. So what is 1 hectare? The conversion is written here. 1 hectare is equal to 10,000 meters. Okay, so 10,000 meters. So if you take the 10,000 meters from here, so there will be two zeros left here. So it will be 2,000 hectares. Okay, so I think up to here it is clear. So now the total area, you got it to be 2,000 hectares. Okay, so now for the rural area, it is given as two-third of rural area. Okay, so you have to write like rural area, then two-third is given already in question. Okay, so two-third of the total area you have to multiply. Okay. So here two-third of 2000 is equal to 1333 dot 33 hectares they got. Okay. And then for urban area, it is one-third. Okay. In the question it is mentioned one-third. So it is one-third into 2000, that is your 666.67 hectares. Okay, so now the intensity of rainfall, it is given in the question is 25, so it is 25 written here. Then we have to assume the runoff coefficient, that is your k. Okay, for k we need to assume. So or in the question it might be given also, or if it is not given, then you need to note it down, the runoff coefficient. Okay, for rural area, it is your 0.30, and for urban area the runoff coefficient is your 0.50. Okay, you can note it down for your future reference. Okay, that is k for runoff coefficient for rural area and urban area. You can use this value for other numericals also. Okay, so now you have got everything. So now we need to just use it in our formula. And since we have the area of two values, so we need to add it up. Okay, so first for first part here, it is one plus sign is given, you see. So first part is they are doing it for rural area. So rural area k value is 0.30. I is same for both the rural and urban, so it is 25. And then for rural area, the area you got it to be 1333.3. Then this part is for your urban area. Okay, and they are dividing it by 360, since in the formula it is there 360. So they are getting the answer, it is 50.925 meter cube per second. And they are converting it to liter per second, that is they got it to be 50925. Okay, so I hope this question numerical is clear to you. It's not that tough. Okay, you write it down in your copy, then later you again do it in your home, then it will be more clear to you. Okay, you are writing or it's finished. Writing is finished. Done. Okay. So let me see how many minutes are left. This way. Okay. So okay. So this is this part. It is all about your this intensity or estimation of stormwater flow and all this part. Okay, so this part, this one sequence, one part, it is finished. Okay, so now next we are going to discuss about our characteristics of sewage, like the same way we discussed the characteristics of raw water. So here also, characteristics of sewage before you are going to treat the sewage in a treatment plan. So you should know how much of in the sewage your what amount of this turbidity or what amount of color or all those things are present in the sewage. So accordingly, you need to treat the sewage before disposing it off to the river or disposal land. Okay, so that's why we need to treat the sewage before disposing it off. So we need to know the characteristics of sewage. Okay, so here characteristics of sewage, it will be easy for you to remember because the terminologies are same. Okay, like that of the raw water. If you see, so first one for your physical characteristics. Okay, so physical characteristics are same like your first one is your turbidity. So here for sewage, turbidity, you see it is written here, sewage it is normally turbid. Okay, sewage is normally turbid, resembling your dirty dishwater or wastewater from baths having other floating matter like fissile matter, pieces of paper, cigarette ends. So all these things. Okay, since it consists of all these things, so sewage it is generally considered it to be turbid. Okay, and then the turbidity it increases as the sewage it becomes stronger. Okay, so stronger, it means that the fresh sewage it is you can say it is more turbid. Okay, so next is your and one more thing here, the turbidity, the degree of turbidity, it is again it is measured by the same instrument, that is your turbidity rod or turbidity meter. Okay, same as your raw water engineering. So next is your color, it is the color of the sewage, it can be no, you can normally see it with your naked eyes. So by the color itself, you get to know what the if the whether the sewage it is fresh or it is a stale sewage. Okay, so if the color of the sewage it is yellow or gray or light brown, then it indicates what? It indicates fresh sewage. You need to know the color. So if it is yellow, gray or light brown, so it is a fresh sewage. And if the color it is somewhat black or dark brown, So it indicates what? It is a stale or septic sewage. Okay, and other colors may also be formed due to the presence of some specific industrial waste. So basically, for fresh sewage, the color it is your yellowish gray or light brown, and for your stale or septic sewage, it is black or dark brown. Okay, so this is the color of your sewage. So next is the order. So fresh sewage. Okay, let me tell you, if the class it ends here, so again you join by 10:15. Okay, I will be sharing one link in your group. So you join by that link at 10:15. Okay. Acha. Then about your order, so the fresh sewage, that is the fresh sewage, that is your, it is odorless. Okay, but if you keep that sewage for 3 to 4 hours, if you keep that sewage, then what will happen? It will become stale. Okay, so why it becomes stale? Because the oxygen present in the sewage, it becomes exhausted. Okay, so then after the oxygen it gets exhausted, so it starts emitting what's odor or foul smells. Okay, and what is that smell? It is that of your hydrogen sulfide gas. Okay, so this is about odor. So let us keep it here up to now. From 10:15 I will be discussing the later part. Okay, so you join by 10:15. Okay, we take a 10 minutes break, 10-15 minutes break. Okay, so let me end the meeting. Okay.